last class. We are going to look at the types of sequences. Of course, we discussed last week that sequences are lines of things or numbers that follows a rule, meaning there must be a rule that is connecting these numbers. So one very definite type of sequence is an arithmetic sequence. Now, an arithmetic sequence is also called, you can also call it as a linear sequence. The word linear means it's straight, it's a line. So this kind of a sequence has a constant difference between each term. For example, when you look at the definition we have here, an arithmetic sequence is a sequence of numbers with a common difference. So it means this is a line of numbers that you have. Okay, who is, let me check. One moment. All right. Okay, I continue. In this case, you will have the first number, the first term. So between the first term and the second term, that difference is the same as between the second term and the third term. So there exists a first term, meaning the first number of the sequence is called the first term. The number that follows the first term, of course, becomes the second term. But how do you see that clearly? We will look at the properties of an arithmetic sequence. But how do you see that this sequence is arithmetic? It means there must exist a constant difference. For example, if you have the sequence 2, 4, 6, 8, 10, and so on. In that sequence, the first term is 2, the second term is 4, the third term is 6, the fourth term is 8, the fifth term is 10. But you realize that between each two terms, there is a constant difference of 2. Between 2 and 4, the difference is 2. Between 4 and 6, the difference between those two terms is 2. Between 6 and 8, the difference is 2. So that difference is existing constantly. So that type of a sequence is referred to as an arithmetic sequence. I will give you an example of a sequence which is not arithmetic. For example, if you have the sequence that we discussed the last time, perfect squares. For example, 1 times 1 is 1. 1 is a perfect square. 2 times 2 is 4. 4 is the second perfect square. 3 times 3 is 9. 9 is the third perfect square. 4 times 4, 16. 16 is the fourth perfect square. So if I continue that sequence, the fifth term will be 25. 5 times 5. The sixth term will be 36. 6 times 6. So this sequence, you realize there is no constant difference. 1, 4, 9, 16, 25, 36, 49. So this sequence is not an arithmetic sequence. Of course, there is a first term, but there is no common difference. So this is another type of sequence, which we will look at later. But right now, today, our focus will be purposely on arithmetic sequence. So the example you see here, 5, 7, 9, 11. 5 is the first term. Now, what is going to be the second term? Is the common difference plus 5, which is 5 plus 2. You can see that in a different color, in the green color. Now, if you want to get the third term, is 5 plus 2 times the common difference. If you want to get the fourth term, is 5 plus 3 times the common difference. And that is how the sequence continue. This is, you can build it. Now, a sequence can go to infinity, meaning it can go endless, meaning it can go to a point that is not ending. It can also end. So there are finite sequences, there are also infinite sequences. Please, if I am talking too fast, you can write in the chat. If you have any question that you want to clarify, equally, you can also write in the chat. It's not fortunate right now. I could not write anything when I am explaining, but some of the notes are very explicit. If you go over the PowerPoint, you will be able to understand what I'm trying to say. Now, okay. Now, today we will look at two forms of formulas that are written for arithmetic sequences. So we are going to look at the explicit function form and the recursive form. So the recursive formula, we will look at it later. And the explicit formula is what you are seeing. You have the formula a sub n is equals to a1, that is the first term, plus n minus 1 times the common difference. Now I explain these two terms. First, a, anywhere in the formula, a1, a sub 1 is referring to the first term. If the sequence is 5, 10, 15, 20, 25, a is 5. That is the first term, the beginning of the sequence. The first number of the sequence is always the first term. Now, d there represents uh, the common difference between, because it's an arithmetic sequence, there must exist a constant difference between the term. So D refers to that constant difference, that common difference that is coming between each term. And N in this formula represents the number of terms. For example, if you are finding the 10th term of a sequence, so in that case, N becomes 10. If we are finding the third term of a sequence, in that case, the n becomes 3. So n refers to the number of terms. So n refers to the number of terms in the sequence, and d refers to the common difference. So a stands for the first term. Now I want you to write in the chart for me, giving this sequence here that you have, a sub n equals to 6 plus n minus 1 times 3. Write down the first 5 terms of the sequence in a list form. Now you can put that on the chart. Write down the first 5 terms of the sequence. Now the first term is a, of course, is 6 here in this case, and the common difference is 3. So write down the first 5 terms. You can see that from the formula here, that the first term is 6 and the common difference is 3. Let me know if you are able to write it, please. Yeah, I see. The first term is 6, 9, yeah, 12, 15, 18. Yeah, that is correct. Masoma, are you there? Do I pronounce your name properly?
Yeah, teacher, I'm writing down that.
Okay.
Yeah.
Yeah, yeah, yeah. Now I will just point out that I know you are typing maybe with your phone or now if you are writing Husseini. Okay. Now I will point out that if you are writing, thank you for writing me your responses. I appreciate it a lot, and it will also help the class when always if you even if you cannot say something, you just write in the chat. That will also help a lot with the continuation. Yeah. Thank you. Thank you. Okay, noted. Yeah, that is accurate. The first term is 6. Noted. All right. Now A sub n is talking about like the position of which term are you talking about? So if you look at the formula an, now a1 now will be the first term, a2 will be the second term, a3 will be the third term, a4 will be the fourth term. I appreciate that you are writing it that way also in your answer forms, that the first term a1 is equals to 6, the second term a2 is equals to 9, the third term a3 is equals to 12, the fourth term a4 is equals to 15, the fifth term a5 is equals to 18, and so on. So which is accurate, which is perfect. So we have the second exercise also there. You can see it, given that the arithmetic sequence is given by the following formula, not in a table form, just write it in a sub n form for me, like in a list form, the first term, the second term, the third term, and the fourth term, only the first 4 terms instead of 5. Write down the first 4 terms of the second sequence. The second sequence is written as 41 minus 4 into a n minus 1. Huh? A n is equals to 41 minus 4 into n minus 1. Before you start writing, maybe you are already writing, but I want to note that this time the common difference is not coming after the bracket, it's coming before the bracket. But always the common difference is the term that is next to the bracket. If you look at the bracket, it can come on the right hand side or on the left hand side. Like in the previous exercise, the common difference is 3. You can see where 3 is. This time, the common difference is minus 4. So please note that. Write the first 4 terms of that sequence. A sub n equals to 41 minus 4 into n minus 1. Write the first 4 terms of the sequence, the first 4 terms. Just list it down instead of putting it in a table. Zara, okay. The common difference is minus 4. Yeah, 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 yeah. Correct. Yeah. Did I say your name properly? Please, I first want to learn the names. Zara, is that the correct way of saying your name?
Yeah, so that is basically the correct way. We call it Zahra, but you can call me Zahra or whatever you are comfortable with.
Okay, Zahra. I will try to put it the right way, say it the right way. Okay, thank you. Appreciate it, ma. Yeah, yeah. Ahmadi, could you check A2? Sorry. Ahmadi, could you check A1? Which one becomes A1?
one minute, teacher.
Could you hear me? I say which term becomes A1? You said A1 is 37. you should see the first term in the formula.
A1 equals to, yeah.
Did you see it?
Yeah, I see that.
Okay, just note that always the first term is in the formula. It's like it's representing A. In the first exercise, the first term is 6. Now, in the second exercise, the first term is 41. Appreciated. Very good try. Good. So we could look at the responses there. So the same thing, the first term from the first exercise is 6. The common difference is 3. So if you put, for example, 1 in the formula for n, a1, that is the first term, becomes 6 plus 0, 1 minus 1 times 3. 0 times 3 is 0. So a1 becomes just 6 because 6 plus 0 is equals to 6. So the first term in the sequence is 6. So the second term becomes a2. If you put a2, a sub 2, this will be 6 plus 2 minus 1. 6 plus 2 minus 1, 2 minus 1 is 1. 1 times 3 is 3. So 6 plus 3, that gives you 9. So a3, a sub 3 becomes 6 plus 3 minus 1. So you could see, you can just substitute directly in the formula to get the responses. For example, if I ask you to find the 99 term, A99. So you just put 99 in the place of n. That will be 6 plus 99 minus 1. So 6 plus 99 minus 1, 99 minus 1, that is 98. So 6, 3 times 98. That's 294. 294 plus 6. That gives you 300. So it means the 99 term of this sequence is 300. So if I ask you to find the 1000 term of the sequence, you can still find it because the formula is there. So please, you need to try to use the formula also. Know how to use the formula to find the first term, know how to use the formula to find the second term, know how to use the formula to find the third term, know how to use the formula to find any number of terms that you are asked to find. It does not matter. Even the 1 million term of this sequence, you can still find it because you can just substitute 1 million for n and then simplify the expression. So always note that when you are giving a formula, you can always substitute to find the number of terms. Are we okay with that? Could you put thumbs up for me? Let me see. Yep. So it is still trying to expand this formula to try to explain it in a better way, but always is a plus n minus 1 multiplied by the common difference. The first term plus the number of terms minus 1 multiplied by the common difference. So anytime you are finding the explicit form of any arithmetic sequence, you should be able to remember this formula, where n represents the number of terms and d stands for the common difference. Do you have calculators with you? Maybe I will want you to use the formula this time around to find the first 5 terms of this sequence. Do you have a calculator with you? Are you able to? Yeah, yeah, okay. So find the first 5 terms of this sequence, the first 5 terms. Substitute in n. For example, the first term becomes just the first number, 2. The second term becomes 2 minus 1 times 0 0.5. 2 minus 1 times 0 0.5. 2 minus 1 becomes 1 times 0 0.5. That is 0 0.5. 2 plus 0 0.5, that will be 2.5. That's the second term. So the third term is A3, and A3 will be equals to substituting n for 3. Put in the place of n 3. Now, if you put 3 there, that will be 3 minus 1. And 3 minus 1 is 2. 2 times half, that's 1. 1 plus 2, that is 3. So you could continue like that to find the first 5 terms of the sequence. Yeah, yeah, Zara. Yeah, correct. Ahmadi, correct. Correct. So the first term is 2. So the second term becomes 2.5, the third term 3. Once you know the common difference is 0.5, you could also just use that and then know that the first term is this, then add 0.5 to the first term to get the second term, add 0.5 to the second term to get the third term, add 0.5 to the third term to get the fourth term, and so on. So that's also one way you can continue or write the sequence. So what you notice is another name for arithmetic progression, arithmetic sequences is a linear sequence, meaning this is giving you a straight line. Anytime you have an arithmetic progression, you can always put it on the coordinate plane. You can put it on the rectangular system. So in this case, you can put it in the Cartesian plane. You can draw a line for it. So that is important for you to note that this is a characteristic for an arithmetic sequence. Anytime there is giving an arithmetic sequence, an arithmetic uh, function, in that case, this can always be a straight line. All right, because there is a constant difference, and this constant difference in terms of the rectangular coordinate system, it is the gradient. So that gives you the gradient, the constant difference that helps you to draw the slope. So exactly the same principles that you have in geometry, that is also here, that is also working on here. So it's important for you to see that's what you are seeing here, that the sequence that you just wrote down, it's on the rectangular coordinate system. It's on a plane. It's in a plane. Uh, Maybe I will want you to write me your names down in the chat. Of course, some of you, I can already see your names, but there are two people that I cannot see the name. So maybe you can just write it down that I know this is this person. Yeah, yeah. So I already did talk about this property. Well, the first property of an arithmetic sequence or an arithmetic progression is that there exists a common difference. There exists a constant difference. Now, the first thing you need to look at for a sequence to become arithmetic, it means there must be the difference between the first term and the second term. That should be the same difference between the second term and the third term. And that difference should be the same between the third term and the fourth term. The difference should still be constant. It should still be common between the fourth term and the fifth term. So if that is existing, then that sequence is arithmetic. So in notation form, writing that in principles, that is what you see here. A sub n minus a sub n minus 1 is equals to the common difference. Anytime you have a line of numbers, you have an arrangement of numbers that follows an ordered principle. In that principle, you looked at it that the first term and the second term has the same difference between the second term and the third term. That difference continues. So in that case, you can say this sequence is arithmetic. So you can see in this case here, consider the following arithmetic progression: 6 plus n minus 1 times 5. So if you look at it, the first 5 terms of the sequence is 6, 11, 16, 21, and 26. So you can see that between 6 and 11, the difference is 5. Between 11 and 16, the difference is 5. Between 16 and 21, the difference is 5. Between 21 and 26, the difference is still 5. And for all the terms that follow in this sequence, because it's an infinite sequence, and for all the terms that follow this sequence, the difference must be 5. You can see an example is given here. The 124th term and the 123rd term, they must have a difference between the two. There must be a difference of 5. So anytime you subtract, take the difference between the smaller term and the larger term, the common difference must be constant. It must be common. So that is the first property that we have for arithmetic progression. The second property is the geometric rule. That is, it can be drawn on a line. You can put it on a graph. So once an arithmetic progression exists, you have a first term, you have a common difference that gives you a line. It's a points on a line. It gives you different points on a particular line. So obviously there exists a common difference, there exists a first term. You can always write the possible number of points that are coming to be on that line. So that's also another property, meaning once it is arithmetic, it means you can graph it. You can put it in the coordinate system. You can draw the graph. You can draw the line. Yeah. You can draw the line. Okay, I want to, not here. One moment. Yeah. All right. Which sequence is explained by the formula? Now, there are different answers here that you can see. Could you write me in the chat which one represents this formula? Which sequence represents this formula? The first term is 42, and the common difference is -3. But always don't look at the first term and just the common difference. You have to look at the list of terms that follow. So write in the chart for me. Yes, Zahra, that is accurate. Just write in the chart which option corresponds to the right answer. Ahmadi, accurate, yes. Ahmadi, that is okay. Mahdiya, yes. Yeah. So you could see that all the sequences that follow A, B, C, D, and E has the first term as 42. And you can see that in the formula that the first term is 42. So the common difference is -3. So to get the next term is just the first term minus the common difference. So this one is giving you 45 plus 3. That is what gives you 45. So that's A is out of it. 46, C is also out of it. So B and D has 39 as the second terms, which is right. 36 as the third term, which is right. 34, that's a subtraction error. You could see. So the correct answer is option D. Yeah. The correct answer is option D. Can you write which sequence appears to be arithmetic? Which one is an arithmetic progression? Which one is a linear sequence? How do you recognize that? How do you know that this is a linear sequence? What tells you? So always remember that the first term and the common difference. There must come a common difference. Write in the chart which of the following sequence is arithmetic. Which one? Which one is arithmetic? If you need help, also you can just put letter E. I will explain. I will go over it. But no worries, we are all here. So yeah, I see that most of you took letter C. Let's investigate each of the sequence. The first one, the first term is 7. The second term is 20. What is the difference between 7 and 20? 13. Then the third term is 32. The difference is 12. The fourth term is 43. The difference is 11. Sorry. Yeah. So it is not an arithmetic progression because you don't have a common difference. Yeah. So I will like give you the next question that you can explain, huh? The next question you can explain your reasoning. Let me just explicit with this one. Let me be explicit with this one. Okay. Now which 37, 30, 24, 19. 37 is the first term. The difference between 37 and 30 is 7. 24 is 6. 19 is 5. So 7, 6, 5. There is no common difference. There is no constant difference. So of course, letter C, there is a constant difference. The difference between 21 and 7 is 14. So that is here again 14, which is 14, which is 14, and so on. So letter C must be the correct answer. Yeah.